Assalamu alaikum students, once more as I told you that we are going to see what is this valency, how is it formed, and how we can derive the valency. It's very easy to know. Usually it's not explained at your level, but I want to explain it to you. But for that you need to know certain number of elements, and with an order as I have taught you, first 20 elements. So we are going to see some of them to some extent. For example, what are these 20 elements that you need to learn? They are being found on page number 48 in your book of chemistry. That's Punjab textbook board. And there you find a periodic table. In the periodic table you find all these 118 elements. And the first 20 that we have just learned them, like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon 18, and potassium 19, and calcium 20. So out of those 20, I'm going to explain to you first 12 here. For that you need to understand many things. Usually I put it that way. You have a cupboard in a kitchen. Okay, there you have different blocks where you keep different things. You have different portions in the safe which is located at your bedroom. So you put different items there. Inside our body we have different organs. They all possess different types of stuff, different types of muscles. In the same way, all these electrons that we learn in the basic structure of atom, that three fundamental particles are present. Though this also for your kind information, that the chemists say that 100 plus little particles or tiny particles have been discovered inside an atom, but three are recognized as the fundamental particles of or subatomic particles of an atom, and they are electrons, protons, and neutrons. As you know, electrons, they revolve around the nucleus, and this is the nucleus, and then protons and neutrons, they are present inside the nucleus of an atom. So our topic is method of finding out valency. I told you many things you need to know. Firstly, what is the formula of finding out number of electrons in each shell? That formula is 2n square. Here, what will you do, or how will you do is, n stands for number of shell, and we have 7 basic shells: K, L, M, N, O, P, Q. I've written here like number 2. This is the number of electrons possessed by these shells. Now, how to check? For example, you can write 2, then instead of n you have to write number of shell. For example, K is number 1 shell. So what will you do? In place of n you will write 1. So now what has it become? 2 bracket or parenthesis, that is 1 square. What is the square of 1? It's 1. So 1 multiplied by 2, what is the answer? 2. So that means the first shell will possess only 2 electrons. What will happen? When first the filling of electrons starts from inside or from the lower shell, that is K, okay, and it goes on towards the outer side. So here we see we have 1 electron. This is hydrogen, its atomic number is 1. This is a simple hydrogen. This is atomic number, and this is mass number. This average mass of hydrogen 1.008. Usually we consider it 1. Now it has 1 electron, and that first electron is in the first shell, that is K. So that means now how will it go? That we want to learn is that hydrogen has only 1 electron in the outermost shell. What will happen? It has 2 options: either to give away this 1 electron and take a charge that would be known as plus 1. Okay, usually plus 1 charge is not written, it's simply written plus sign. Another option, if it takes 1 electron from somewhere, so that means its valency would become 1. This is its task. Either it wants to give 1 electron away and empty the shell, then it has no tension. Or it want to make it stable, because we learned that in K shell there has to be 2 electrons. Okay, and how do we derive? We'll try that, like 2, 1 square. As we know, the square of 1 is 2, so 2 into 1, 2. Okay, so this is how it is going to be. So that means K shell has 2 electrons. Now these both the atoms, they would prefer to have 2 electrons. For example, we know here, so that means what are the valencies, possible valencies, which could be for hydrogen? It could be +1 or it could be -1. These are the 2 valencies. Okay. In case of helium, how many electrons you see here? You see here 2 electrons. So that means its outermost shell is complete. It has no valency. It is known as noble gas. Any element which has a complete outermost shell is known as noble gas. We go to lithium. Now please try to understand its case. K shell's capacity, as we relate it here, it is 2. It has 2 electrons in the outermost shell, so that means nothing is required. This is a complete shell. We talk about the third shell, and here some of the students, they made presentations and they put all the electrons in the one shell. That is wrong. It's not that way. I just held it on. I just kept quiet because I wanted to record this lecture for you in order to make you understand. So I didn't say. I simply appreciated that. Okay, well done, well done. But here, my dear, there are 3 electrons. 2 will come in the first shell. 1 will go in the next shell, and 1 is here. Now, what is the requirement of shell 2? This is L shell, as I have related. It requires 8 electrons. How? That also we would see 2 into 2 square. Now it has become 2 multiplied by 4 is equal to 8. So that means second shell has to have 8 electrons. But lithium is having only 1 electron. So in order to complete this shell, it needs 7 more electrons. There are 2 options, either to complete it or to empty it. If it wants to empty, it has to give this electron away. So giving this electron away means the number of electrons will be less than 1 and number of proton would be more. So what valency you expect for lithium, it's most probably it's 1 plus. Okay, no option of plus, also -7, because no one is going to give it 7 electrons. Okay, so that could be the valence. We talk about beryllium. Maybe with the passage of time you will find it easier. Beryllium, we say it's number 4. Its atomic number is 4. Mass number is 9. How many electrons it will have? Atomic number is 4, so it will have 4 electrons definitely. So 2 electrons here in the first shell, that is K, it's completed. 2 electrons left for the next shell, that is L shell. We know what is the demand. N has to have 8 electrons. How many electrons are there? Only 2. So it means either it has to give 2 electrons away, or it has to grab or to find out 6 more electrons, which is quite a difficult job. So then what valency I am expecting for beryllium, that most probably should be 2 plus. Okay, very rare, -6 is not possible, so we will go with 2 plus. We go to boron. We go to boron. Atomic number 5. Mass number 11. How many electrons? 5. That means 2 here. So that means 2 plus 3. 3 plus 2, 5. Total is 5. 2 in the first shell, K shell. That is complete. In the L shell, how many we have? We have 3 electrons. How many are required? 5 more. So do you think someone is going to, or some atom is going to donate us 5 electrons? Very tough ask. So most probably the most expected should be +3. But if someone gives, or not someone, if some atom gives 5 electrons, so maybe there is exception, or there is the case that maybe it could be -5. Okay, but most probably 100%, or it's not 100%, but just 90%, it should be the case that it's going to be +3. Carbon, very interesting case. We know K shell is complete, atomic number is 6. So that means 2 here, 4 left in this outermost shell, and we are very closer here to this L shell. You just see here, L shell needs to have 8 electrons. Now when it requires 8 electrons, so that means there are 4 here. So now what is difficult and what is easy? To give out 4 electrons or to take 4 electrons? And it's very simple answer. Giving away 4 electrons is as simple as taking 4 electrons. So that means it has 2 options and both the options are valid. Either give away 4 electrons and be plus 4, or take 4 electrons and be minus 4. So this is the confined valency for carbon. Okay. Now nitrogen, here like now the things are going to change. 7 electrons. How many? 7 electrons. So when it's 7 electrons, that means how is it going to be? 7 electrons, that means 2 in the first one, 2, 4 plus 1, 5. So that means it's now 5 plus 5 plus 2. So that means 7. Now how many electrons are there in the outermost shell? 5. How many are required? 3 more are required. So again, first option would be minus 3, but the second option, of course, it could be plus 5. If it's not getting 3 electrons, so it can become 5 plus by donating these electrons. If it gives away these 5, so it will become plus 5, but if someone gives 3, so then it means it will become minus 3. Oxygen, now the case has become very simple. Oxygen, we know K is complete shell with 2 electrons. We know it's L shell. It requires how many electrons? 8 in order to be stable. So what will happen? It has 2, 4, 6. How many are less than? 2 are required. So if it receives 2 electrons from somewhere, its valency would become minus 2. And this is the most expected. It's very rare. Somewhere it may become plus 6 by giving all the electrons. Okay, that's a different study. We would learn somewhere that sometimes it does become plus as well. Fluorine, there is no argument. It has 7 electrons here. 2, 4, 6 plus 1, 7. Okay, now 2 electrons here. Total is 9. 7 plus 2, 9. So it requires how many? It requires only 1 electron, so the valency is going to be minus 1. It's a very special element, the most electronegative element in the periodic table. Okay, then of course it's 10, 20. 10 is atomic number, 20 is the mass number. You see 2, 2, 4, 6 and 2, 8. All 8 electrons present. So K shell is complete, L shell is complete. So what is it going to be? Noble gas. It's going to be a noble gas. Okay, so any valency? No. 0 valency. It has no valency.